Welcome. So quickly we'll look into squeeze theorem. Squeeze theorem is a way for us to evaluate some limits we can't handle by L'Hopital, factorizing, or any algebraic process to be hard to obtain. So the squeeze theorem is saying something. If we can squeeze a function, let's say f of x, in between two other functions, if you can squeeze in a function in between two other functions, and we take the limit of this function, and also take the limit of this function, of the endpoints. If the limit of this function g of x is equal to the limit of this function p of x, if these two have the same limit at x equal to x naught, it means that their limit, once the two are equal, once this g of x and p of x is equal at a point x equal going to x naught, then the limit of the function squeezed in between, is also equal to L as x tends to x naught. I will explain this statement, this theorem, with some example. Let's just take one example for this. Yes. Let's solve this. Let's evaluate the limit as x approaches 0 for x squared sine 1 over x. Now, if we take the limit directly, what happens? Here gives us 0. Here gives us sine 1 over 0, which is undefined. We can't take the sign of infinity. So this won't work that way. So in a case like this, what do? We know that from trigonometry, from basic trigonometry, from trig, the range of sine x, the range of the sine function sine x is from -1 down to 1. The sign of anything, the answer must be in between -1 to 1. So I'm saying that the sine function, the sine of 1 over x, precisely, must be in between two things. What and what? -1 and 1. Yes. From trigonometry, from trig, we know this already. So now what do? If I multiply all through by x squared, yes, multiply all through, through by x squared, what happens? If we do that, it's going to be minus x squared is less or equal to sine 1 over, x squared sine 1 over x, less than or equal to x squared. Now, we are not able to squeeze in the function we are trying to evaluate in between two functions. So from now definition, our g of x is this, our p of x is this. If we can evaluate these two limits and they are equal, then that's the limit for our function here. Yes, let's try it out. Now, what do we do? What do we do? We simply go ahead to evaluate the limits on our boundary. So let's see what happens. The limits as x approaches 0. For the left hand side, I'll have minus x squared. And this is what? 0. Yeah, because when x goes at 0, I'll have minus 0 squared, which is what? 0. Also, the limits for the right hand side, limits as s goes to 0 for s squared. What is it? 0. Since the limit of this point, and the limit of this point are equal, the function squeezed in between these must also be equal to 0. Therefore, we can say that the limit of this function is equal to 0. Squeeze theorem, also known as pinching theorem or sandwich theorem. Provided you can squeeze a function in between two other functions. Once the limit is equal, the one in the middle you squeeze inside is also equal as x tends to a particular input. Thanks for watching. If you understood something, please like the video.